Welcome to the 9th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss motion, position, distance, and displacement. In the following couple of videos, we will describe the movement of objects in a physical sense. In physics, motion means that an object changes its position with respect to a reference point in a given time. The concept of motion and the ways we think about it might seem very trivial now, but the field was only developed in the 16th to 17th centuries AD by such famous physicists as Galileo Galilei and Isaac Newton. The field of physics that studies the movement of objects and the related concepts of force and energy is called mechanics. We distinguish between two different branches of mechanics. Kinematics describes the motion of objects in terms of position and time without considering their causes. So, for example, if I ask you to tell me the distance a car traveled based on its velocity, you will use kinematics to answer the question. On the other hand, dynamics describes the motion of objects due to the effect of their causes, such as forces. If you calculate the movement of a rocket based on the thrust and the gravitational force, you use dynamics. There are several different kinds of motion. The two big groups are translational motion and rotational motion. During translational motion, the points of an object do not move compared to each other. This means that the object is not rotating and it will not become deformed. Its shape stays the same. The simplest case of this is linear motion, which is a one-dimensional motion along a straight line. Rotational motion means the circular movement of an object's points around an axis. Think, for example, about the rotation of the Earth around its axis, which causes the cycle of day and night. Now we will only study linear motion, leaving the other kinds to a later time. The first important concept of motion is position. It means the location of an object at a particular moment relative to a reference point, which we will call the origin. Position is a vector quantity. It has a direction from the origin. The next concept is distance. It is the actual length of the path of the object's motion. Distance is a scalar quantity. In this figure, for example, a person took this curved path between the cities A and B. The distance he covered needs to be measured along this curved path. So not just simply the straight line distance as the crow flies. Finally, we have displacement, which is the change in the position of the body in a specific direction. Unlike distance, displacement is a vector quantity. Take a look at this figure. Even though the person took this curved path, his displacement should be measured on the straight line connecting his initial position to his final position. So the displacement does not depend on the path taken, only on the locations of the start and the end points. To understand the difference between distance and displacement better, think about swimmers. In the Olympic Games, swimmers show a fantastic effort as they swim back and forth in the pool several times. The distance they cover can be several hundred meters or even multiple kilometers, but their displacement in the end will be zero. They arrive back at the same point where they started the race. You can express the delta D displacement vector by subtracting the initial position vector, di, from the final position vector, df. Thank you for your attention and see you in the next video.